morning everyone. So let us start our class. So till question number 5 we have done, right? So today from question number 6. PQ and RS are two mirrors placed parallel to each other. An incident ray AB strikes the mirror PQ at B. The reflected ray moves along the path BC and strike. Okay, there is some part of physics in this question. So this reflection you will get in class 10. Okay, in class 10 physics part you will get. Just you see once. Let's say this is a mirror. You see these dashed lines are given. Okay, these dashed lines are given. You see in PQ and RS. So if this is a mirror, this is the reflecting part of the mirror. This side. Okay, this side is the reflecting part. And this side is the rough part. If you have seen a plane mirror, broken plane mirror, then you will see the first, the top part is the reflecting part, okay, where we see our reflection. And in the bottom part, there you will see brown color or sometimes silver color, rough part is there, where light cannot pass. So this is indicated by what? These dashed lines. Understood? Okay. So this is a plane mirror, okay. So what happens whenever light rays falls on it, which you will learn in physics actually. So this is a light ray came from directly from sun. This is known as incident ray. This incident ray when touch the mirror from here it reflects back. Okay, this is known as what? Reflected ray. So this is what? This is a reflection in a plane mirror. So this thing is happening over here. Okay. So let us draw the diagram at first. And one formula of physics will be applied here, which is not there in maths, okay, right now. So that formula we have to use there to solve this question. That is known as laws of reflection, okay. So you will get that one in class 10, by the way. So draw the diagram, everyone. See, this is the incident ray. Okay, this is given as what? AB. And this arrow is why given? Because it is showing that light has came from this direction. Okay, so this is the incident ray. As soon as it touches the mirror, it reflects back. As soon as it touches the mirror, it reflects back. Okay. Again you see, this reflected ray touch this mirror. So again a reflection will be there. Again from this mirror also a reflection will be there. See, from here, this is the incident ray. It reflected in this way. In this way it reflected, it touched this mirror, and again what happened? Again reflection was there. Okay, again reflection was there. So this is again reflection. So this is the diagram. Understood? In physics you will get this ray is known as what? Emergent ray. Okay, it is given or what over here? Reflected ray moves along the path BC and strike the mirror at C. It is not given in this question, okay? But this is incident ray, this is reflected ray, this is known as emergent ray. You will get that in physics part, okay? Okay, this is what? B, over here C, and over here it is what? B, okay? So this is the diagram. So now in figure PQ and RS, definitely we can say these two are what? Our two parallel mirrors, okay, to each other. They are parallel. So given, no need to write mirror, okay. Simply we will use what? PQ is parallel to what? RS. An incident ray AB strikes the mirror at strike the mirror PQ at B. The reflected ray moves along the path BC strikes the mirror RS at C and again reflects back along CD. Prove that what? What we have to prove now? To prove AB should be parallel to CD. We have to prove this AB is what? Parallel to CD. They are always parallel. Okay, they are always parallel. We have to prove that one. And I have said if parallel is given, then alternate angle, corresponding angle. Okay. And if we have to prove parallel, then at first what? We have to show it is alternate, then only parallel. If parallel, then alternate, alternate, then parallel. So we have to show parallel, right? So before we have to show what? Alternate, then parallel. So this will be the process, okay? Okay. So now see, one law will be used over here. At first you write construction. At first you write one construction. Okay. This will be the construction. Okay. Say ABCD is there, PQRS is there, EF. Say ABCD, this is E, and this is say F. Okay, ABC, this is EF. So this we have drawn. Okay, this is known as what? Normal. Now what is normal? Normal is a physics term. Okay, simply in mathematical term, this is what? This is a perpendicular. In physics, in optics, we say it is what? Normal. Okay, so normal is nothing. Normal is 90 degree only. So what we will say over here? Construction BE perpendicular. This is BE, right? This is BE and it is perpendicular, isn't it? Perpendicular means what? 90 degree. This is like that. This is what? This is 90 degree angle. So BE perpendicular to PQ is drawn, and similarly what? CF perpendicular to what? RS is drawn. BE perpendicular to PQ is drawn. CF perpendicular to RS is drawn. Okay, done. Now we will start the proof. Okay, say give the name of this angle. Okay, then it will become a little bit easier to understand for everyone. Say I will name this angle as 1. I will name this angle as 2. I will name this angle as 3. I will name this angle as 4. Then it will be a little bit easy to understand. Okay, or else we have to write so many angle names. Okay. So now you see what is the law of reflection. Say this is a mirror, okay. You keep in mind one thing, this normal, this is actually not present, okay. This is an imaginary line that we have imagined, understood? How you see, say a light ray is coming like that. From any direction it may come, say it came like that, okay. This is the incident ray. Now as soon as it touches the mirror, it reflects back in such a way. See, it could have reflected like that also. See, the incident ray came. It could have reflected like this also, but it will not reflect like that. It could have reflected. It could have reflected like this also, but it will not reflect in this way also. Okay, it will reflect in such a way that if you draw a perpendicular over here, which is known as normal, by the way, means if you draw a normal over here or perpendicular say, then this angle and this angle will always be equal. This is known as, by the way, in physics it is known as angle of incidence, and this is known as angle of reflection. You will get in class 10. So what I am saying, that this angle formed by the incident ray and this angle formed with the reflected ray will always be what? Equal. This is known as laws of reflection. Means this property always follows whenever reflection takes place. Always. Otherwise reflection will not take place. This property will 100% follow. Means say if a light ray is coming like that, say like this it is coming. Say this is the normal. Then it will reflect back also like this. This angle and this angle I will be always equal to what? R. Always. So this property we will use, which we have definitely not got in our exercise. This is a property of the physics. Okay. So now what I will say that this angle 1 and angle 2 will be what? This is incident ray. So angle 1 is the angle formed by the incident ray along with the normal. See, this angle is incident ray and between normal, and angle 2 you see between normal and what? Reflected ray. So I can say that now proof, now angle 1 will be equal to what? Angle 2. Understood? This is angle of incidence, this is angle of reflection, and angle 3 will be equal to what? Angle 4. Understood? Reason what you will say? This is laws of reflection. This is what? This is laws of reflection. Okay, done. Okay, now one more thing you have to understand, that is what? Okay, so the battery is low, so that's why the video stopped, okay, in between. So okay, where we were, this we have got by what? Laws of reflection. Angle of incidence, angle of reflection is equal. Over here also, angle of incidence and angle of reflection will be what? Equal. This is the incident ray over here, again it reflected back, so over here also the angle will be equal. Now the one more thing that you have to understand is what? Say this is a parallel line, okay? Say this is a parallel line, this is another parallel line. You can imagine the railway track for that, okay? Your railway tracks definitely you have seen. So these are the two railway lines, okay? They are always what? They are always parallel. Now between them you will see like that, isn't it? They are what? They are exactly what? Perpendicular, isn't it? They are exactly perpendicular. So this is a railway track. They are what? Perpendicular. You see? This is perpendicular. This is again on perpendicular, means what? 90 degree, 90 degree, 90 degree everywhere, okay? So see, if these two are parallel and they are perpendicular, then they will also be what? Parallel. You see? These two are also what? Parallel. So what I am saying, if there is two parallel lines, say if this is perpendicular to this one, if this line is perpendicular to this parallel line, and if this line is perpendicular to this parallel line, then these two lines will always be what? 100% parallel. If this line is perpendicular to this parallel line, if this line is perpendicular to this parallel line, then they will always be what? Parallel to each other. So in the railway track you can see the between that stone is there, na? That stone kind of thing is there. So that is what? They are parallel to each other. Because what? They are perpendicular to the parallel lines. So they are also what? Parallel to each other. I mean this line is a parallel perpendicular to this one, okay? And one more line is there. This is perpendicular to this one. Then these two will be what? Anyhow, again parallel. So this is a property, okay, of parallel lines. Understood? So now you see PQ and RS are what? Parallel, it is given. And this BE is perpendicular to PQ and this CF is perpendicular to this what? RS. So this BE and CF will be what? Parallel to each other. Because these two are parallel and this is perpendicular to this is perpendicular to this. So these two will be indirectly what? Parallel to each other. Understood? So now this we have to say this one, that say now PQ parallel to what? RS. PQ is parallel to RS, comma BE perpendicular to PQ. BE perpendicular to PQ. By construction we have said, no, that BE is what? Perpendicular to PQ, and CF is perpendicular to RS. So what we can conclude now, that these two are parallel. This is perpendicular to this is perpendicular to this. So we can conclude that therefore BE will be parallel to what? RS. What we can conclude? That the normals we have drawn, or the perpendiculars that we have drawn, BE and CF, they are parallel to each other. By looking also you can say what? They are parallel to each other. Okay, done? Okay. So now you see, if this BE and CF are parallel to each other, then there is an alternate angle over here. Can you say or can you see what is the alternate angle? Just look the diagram properly and find out. If you can't find, then simplify the diagram. That this is BE, this is CF. What is the alternate angle? Actually, at first, which one is the transversal? So you see, this is the transversal. So this angle and this angle is definitely what? Alternate angle. If still you have confusion, then you rotate this diagram. Say this BE you draw in this way. Say this BE I will draw in this way. This CF I will draw in this way. And this is the parallel line. So this angle and this angle is what? Alternate angle. This looks like a Z, isn't it? This looks like a Z. This looks like a Z. Alternate angle will always form in Z shape, okay? Alternate angle will always form in Z shape. The interior alternate angle actually I am talking about. Okay? The interior alternate angle. Not about the exterior alternate angle. So see, Z shape. See, the Z is rotated. See over here. Now try to find over here which two angle will be alternate angle. Clearly this is the parallel. This is the parallel. So angle 2 and angle 3 will be what? Equal. Why? Because alternate angle. Because we have said now that BE is parallel to RS. So since BE is parallel to RS, so what we can say, which implies angle 2 will be equal to angle 3. What is the reason? Alternate angles. Alternate angles. Done? Okay. Now see how you will solve. Okay. All the things are done. Now simple 2 or 3 steps are left. After that we will get the answer. Now first thing what I will do, angle 1 plus angle 2. What I have done? This angle 1 and I have added this with what? With angle 2. Now angle 1 plus angle 2 will be equal to what? Now you see, angle 1 is equal to angle 2 or not? So in place of angle 1, I can write angle 2. Angle 1 is totally equal to angle 2. So in place of angle 1, I can write angle 2. So in place of angle 1, I will write what? Means this is angle 1 plus angle 2. So in place of angle 1, I will write what? Angle 2. Like that, okay? So in place of angle 1, angle 2 and then plus angle 2. Understood? Angle 1 is equal to angle 2. So in place of angle 1, I have written angle 2. Now a question you may ask that why in place of angle 1, why in place of angle 1 I have written angle 2. In place of angle 2 also I can write angle 1. Means I can write like this also. Say angle 1 and in place of 2 also I can write angle 1. Same thing, angle 2 is also equal to angle 1. But this one I will not write. Why? Because of this condition, you see. 2 is equal to 3. So I need this angle 2. And similarly I will require this angle 3 also. Understood? 1 I don't need, okay? There is no requirement of this angle 1. What is the requirement? This angle 2 is the requirement. So you have to bring angle 2 only. Okay? Understood? Why you cannot write angle 1 over here in place of angle 2? You have to write angle 2 only in place of angle 1. So what will be angle? So what will be angle 2 plus angle 2? Angle 2 plus angle 2 will be what? Twice of angle 2. Angle 2 plus angle 2 is what? Twice of angle 2. Done? Now, and similarly over here, angle 3 plus angle 4. Angle 3 plus angle 4 equal to, now I need what? Angle 3. So in place of angle 4, what I will write? Angle 3. Angle 3 plus angle 3, which will be equal to what? Twice of angle 3. Now you see, okay? See in the right hand side, this is your left hand side and this one is your right hand side, okay? This 2 and this 2 is equal. 2 and 2 is equal only, okay? See, this 2 is what? This 2 is your number 2, okay? 1, 2, 3, 4, 5, 6. This 2 is your number 2. And this 2 is your angle 2. So if anyone don't write like that, okay? Angle 2 plus angle 2 will be angle 4. This is different, okay? This is not that 2 plus 2, 4. This is angle 2. I have given the name as angle 2. Actually this name is what? This angle 2 name is what? Angle EBC. Angle EBC plus angle EBC. So you cannot write angle 2 plus angle 2 angle 4. Okay, this is actually angle EBC plus angle EBC. I have given the name to be angle 2. Okay, but this 2 is what? This 2 is your number 2. Two things are there, like x plus x is what? Twice of x. Y plus y is what? Twice of y. So this is the number 2. But this is what? This is angle 2. So don't write angle 2 plus angle 2 angle 4 like that. Okay. Now you see, in the right hand side, this 2 and this 2 is same. They will get cancelled. They are exactly same. This is also number 2. This is also number 2. Their value is exactly same. Now remaining these two part. Angle 2 and angle 3 are also same. Already we have got over here. Angle 2 and angle 3 is also same. 2 and 2 is also same. So I can say this complete part and this complete part is same thing. Understood? These two same. Angle 2, angle 3 same. So twice angle 2, twice angle 3 is also same. So therefore what I can conclude? So therefore what I can conclude now, since these two part is exactly same, since the right hand side is exactly same, so the left hand side will also be exactly same. That is angle 1 plus angle 2 will be equal to what? Angle 3 plus angle 4. Understood? Since the right part is same, this is simple rule na? If the right hand side is same, the left hand side will also be same. So if the right hand side 2 is same, angle 2 angle 3 is same, so the left part angle 1 plus angle 2 will be equal to what? Angle 3 plus angle 4. Which implies, now what is this angle 1 plus angle 2? What is this angle 1 plus angle 2? Now you have to write the proper name. Angle 1 plus angle 2 is this complete angle. If you add this angle plus this angle, you will get this complete angle. So what is the name of this complete angle? Now there is no number. Don't write 1 plus 2 is equal to angle 3. Cannot do like that, okay? Don't write 3 plus 4 is angle 7. This name I have given, okay, in the question. Actually they are angles. So angle 1 plus angle 2 is what? This complete angle. So what is the name of this complete angle? Angle ABC. Angle ABC. This is equal to angle 3 plus angle 4. What is the name of this angle 3? This is angle 3, and if you add angle 4, then this will be what? This complete angle. So what is the name of this complete angle? Angle BCD. Done. This is what we need. Okay, angle ABC is equal to angle BCD, and our answer is done. Why? Now you see this angle ABC, this angle ABC, and this angle ACD. They are what actually? Try to find in the diagram they are what. If you can find, then very good, and if you cannot find, then you see this is the parallel line. This is the parallel line. Incident ray, reflected ray, and then again this reflected ray, you mean emergent ray. So this angle 1 plus angle 2 is what? This angle. This angle 3 plus angle 4 is what? This angle. I have not drawn the construction. This construction is creating this difficulty, okay, to understand. If you don't draw the construction, then you see this angle and this angle is what? They are nothing but they look like what? They look like alternate angle. See, like Z, isn't it? Like that Z. This Z is slanting like little bit, it is rotating in this way. This is nothing but what? A Z. So you see, this is the transversal. So this angle and this angle looks like what? Alternate angle. So what we have said, that they are equal. Okay, they are equal and they are alternate angles, and they are what? Alternate angles. By different way, we have shown what? That these two are equal, and they also look like what? And they are what? Alternate angles. So simple, if they are alternate angles, so If parallel, then alternate, and if alternate, so what will be your parallel lines? This like this, isn't it? Like this. This angle is equal to this angle. So what is the parallel line? This is the transversal. So what is the parallel line? This one and this one. Means what? AB and so AB parallel to what? CD. With this exercise also completed. Okay. Any doubt regarding this exercise? You will ask. Okay. Now we will move to our last exercise, which is comparatively easy, except for one question. Rather, all questions are comparatively easy. Okay. Okay. So this exercise is done. So now let us discuss the property of the third exercise. In first exercise, the property was linear pair and vertically opposite angles. Then we have learned about alternate corresponding parallel lines, transversal, interior, exterior, same side of the transversal. Okay, co-interior angles are supplementary. Okay. Now what we will learn? Two property. One property already in the last class I have said that what? Already I have used and I have said that this property remains where? In the third exercise. But already we have discussed that in a triangle there are what? Three sides and three angles. Three angles, okay? One angle, second angle, third angle, okay? So if you add these three angles, always it will be what? 180 degree. Don't say this to be supplementary, okay? Supplementary is only for addition of two angles, not three angles. Understood? So this will be what? Addition will be what? 180 degree, not supplementary, okay? Three angles addition, if it is 180 degree, then it is not supplementary, only two angles. Okay, any triangle you draw, say like this, and like this. Say angle 1, angle 2, angle 3. It will always be 180 degree. You can draw, you can measure by protractor and you can check. It will always be 180 degree, okay? This is the first property. This is known as what? This property is known as angle sum property. This property is known as what? Angle sum property, okay? Angle sum property. Sum of all the angles of a triangle is what? 180 degree. This we have already used in our second exercise, okay, in one question. If you remember, we have already used, I think so. I think so in question number 5 we have used this property, isn't it? This is the first property. Now see the second property. That property is what? That property is exterior angle property. Exterior angle property, okay? Exterior angle property. So see, if I draw a triangle, now I have said how many angles are there? Three angles are there. 1, 2 and 3. But these three angles are not exterior angles. They are interior angles. They are inside the triangle. So what will be the exterior angle? If I extend this line, if I extend this side of the triangle, so then this angle will be what? This angle will be your exterior angle. If I extend this side over here, then this angle will be your exterior angle. If I extend this side over here, then this angle will be your what? Exterior angle. If I extend this side, then this angle will be your exterior angle. This side, then this angle will be exterior. If I extend this side, then this angle will be your what? Exterior angle. Understood? Sorry, this one is not exterior angle. This angle will be your what? Exterior angle. So this is exterior angle, okay? So these are the exterior angles of a triangle. And for this one property is there, you see. What is the property? Say for example, this is a triangle. This is angle 1, this is angle 2, angle 3. This one I have extended. So this is what? This is my exterior angle 4. Now you see with this angle is what? 4 and 3. 4 and 3 are what angles? So this is ABC. Now I have said, I think so in the second class of this chapter, that two angles, if they have a common vertex, two angles or three angles, whatever, two angles only you say, if they have what? Common vertex, then they are known as what? Adjacent angles. I have said, na? This is an angle. If two angles they have common vertex, then they will be known as what? Adjacent angles. Understood? So these two is your adjacent angle. So forget about this angle. So the property is like that. Angle 4 will be equal to what? You have to forget about your adjacent angle. Don't consider this adjacent angle. Okay. Now then what? Accept this adjacent angle. Forget about this angle. What are the angles that is remaining? 1 and 2. So remember the property is what? Angle 4 will be equal to angle 1 plus angle 2. This is exterior angle property. Okay, this is exterior angle property. That this exterior angle is equal to the sum of the remote interior angle. Understood? This exterior angle is equal to what? Sum of the remote interior angle. Exterior angle of a triangle is equal to the sum of the remote interior angles. This is what? This is your exterior angle property. Understood? So let us see the diagram. Exercise we will start tomorrow. So this is 1, this is 2, this is 3 and this is 4. Okay. So over here angle 4 is the exterior angle. So this will be equal to what? Forget about the adjacent angle. This will be angle 1 plus angle 2. So this is the exterior angle. So over here angle 4 will be equal to what? Now what is the adjacent angle over here? Forget about this adjacent angle. The angle touching with the exterior angle is what? It's adjacent angle. Okay. So it will become what? 2 plus 3. So this is the what? This is the exterior. This is the remote interior angles. Remote interior angles. This angle is what? Adjacent angle. For this exterior angle, this is the adjacent angle. For this exterior angle, this is the adjacent angle. And if I draw over here, then this will be the adjacent angle. Okay. Say 1, 2 and 3. If I extend in this way, say over here, this is 4. Okay, this is 4. So what will be angle 4 will be equal to what? So over here, angle 4 will be equal to what? This is the what? This is the adjacent angle, isn't it? This angle 2 is what? The adjacent angle. So 4 will be equal to what? 1 plus 3. 1 plus 3. So this is exterior angle property. Okay, how this property has came? In next class I will show that why this is like that, why that 4 is equal to 1 plus 3, why that addition is there. Okay, I will show in the next class and then we will start the exercise. This is comparatively easier exercise except for one question. The questions are very easy in this exercise. Okay, so that's all for today's class. Thank you.